For Euler's method, like you're given in problem number 8, with Euler's method, you're given a differential equation, and you're using that differential equation to estimate the slope at any point in time. With Euler's method, you're given an initial value, and what I did on this graph is I took and I graphed the initial value. The initial drug concentration is 0.025. So when time is 0, you have a concentration of 0.025. That's this right here. And then you use the values in the differential equation to come up with the slope of this line. And I used an Excel spreadsheet for this. But when time is 0, the concentration is 0.025. And so the concentration of the drug at any time is given by this formula. The concentration of the drug is the value of C times e to the negative t. So when t is 0 and c is 0.025, you get C 0.025 times e to the negative t power. T is 0 at this point. E to the 0 power is 1, and so this just gives you 0.025. If you take this line and draw a slope, the line of a slope with a straight line with a slope of 0.025, you get this line. And that line extends forever. But we want to take into account that our change in t here is 0.5. So we have increments of 1/2. And so for 0.5 units, I want this straight line with the slope of 0.025. So to get the y value of this point, you want to take the previous y value, 0.025. So this would be y0 is 0.025. y1, start with the previous y value, 0.025. And then add on the slope for however many units you go to the right. In this case, we're only going half a unit to the right. So multiply by 0.5. Multiplying by 0.5 is the same as multiplying by 1/2. It's going to give you 0.0125, which when you add that to 0.025, you're going to get 0.0375. That gives you the new y value of the point. So when t is 0.5, the value for c is 0.0375. This is an approximation. And then you use the values at this point. Here the t value is 0.5, the c value is 0.0375, along with your derivative to calculate the next slope for the next line segment. So on this next value, this would be from C, 0.0375, times e to the negative t, times e to the negative 0.5. So 0.5. If you type this into your calculator, you'll see that you get approximately 0.22745. The slope is a little bit less steep than our previous slope. So this line, it's hard to tell, but it doesn't go in an exact straight line. It's starting to level out a little bit. On this second line segment, our slope is 0.025. 0.22745. When you're using Euler's method, you want to try and keep all the digits, as many digits as possible, in your calculator or whatever program you're using, in order to keep the accuracy in order to keep your answer as accurate as possible. Anyway, to get the next y value, which is this 0.0488725, we're going to start with the previous y value. So this one up here would be y2. Start with the previous y value, 0.0375. And then add on the slope, 0.022745, times the increment, times 0.5. And that's going to give you this value. And again, I worked this out on the on Excel. And if we wanted to find the approximate value at 1.5, then you would calculate the slope again and go through another iteration. Right here, this is the approximation of the concentration after 1.5 hours, or after 1 hour. After 1 hour. After 1 hour, there's approximately 0.048872 micrograms per milliliter.